Okay, ladies and gentlemen, I think we had a bunch of very high quality speakers today, but we are very happy that we have here the star of the show to end the day with his presentation. He has more than 33 years experience in the field.
Yes.
He's well known from Climate the Movie, of course, and his speech, his interview with Tucker Carlson. So please welcome on stage Mr. Willie Soon.
Thank you. Go to the left. I mean, there's a teleprompter here, so I'm trying to tell you, I'm not cheating. I won't read this. Any case, first thing I need to do is to get rid of my name tag in case somebody want to throw tomatoes. Let's have a sip here. It's probably not vodka. Well, thank you very much for coming. I'm so happy and to be here. I first and foremost want to thank my friend Marcel Kroc, and then I want to congratulate all of you and Clintel for making it to the 5th years of their existence. And it is a distinguished honor to be able to speak with you, to share with you all my scientific work. Obviously that I have so much to say that I say that if you were to not catch anything that I say, please come and visit the center that I created, Center for Environmental Research and Earth Sciences. The website is series-science.com. We have a lot of material there from both scientific and also news articles. But the first thing I must start is to thank also my 2 co-authors and colleagues. We've been working very closely together. So every time you hear Willie Soon, you think about Michael Connolly and Ronan Connolly. Obviously, whatever that I say that is wrong is actually my own, and those guys deserve all the good credit for all the powerful work that we are doing. I have a slight disadvantage. I have to tell science, so I have a lot of graph, right? They were so worried that I have so much graph that we should not really, get into too much details, this and that. But really, serious, science is all about details and numbers, so please be patient with me, right? I try to explain as slowly as I can. So to start is that I think we should distinguish between what we call science. Normal people like us just do science. But then there's a kind of science that is called trademark science. It's the IPCC type, obviously. But they are interested in something else. Yeah, we will talk about this. Although it's a bit unscientific. What I'm trying to convey here is very simple. IPCC is doing cartoon science and gangster science. We're doing just normal science. But scientifically, it's very, very interesting. Like I start my career being just a normal scientist, don't even know what a sunspot is, but I got a prestigious position at the Harvard-Smithsonian Center for Astrophysics. Since I was doing a little bit of physics, so they say that this kid is all right, so let him come. I don't even know what a sunspot is, but then I ended up to be somewhat of an expert on sun-climate connection. Because once you study how much the sun changed, and then you really realize that the next question, if it does change substantially, what does it do to the climate system, is a very natural question, I think. Okay? So I'm going to frame a lot of this in terms of the puzzle. The outline for the talk today is, like I say, you see a lot of items, but please don't worry about it, right? I can do that in 2 minutes. But we want to explain very slowly what UN panel call the detection and attribution science, right? Detection just simply means basically, you need a signal, isn't it? Whether you detect a signal or not. When you say global warming, how does global temperature get calculated, isn't it, right? So I'm trying to point out the problem, okay? Mainly that when you start putting up graphs that look like IPCC graph, that I try to encourage you from not using those graphs anymore because it doesn't represent climate change. It represents urban heat island effect, okay, if I may. And then we make our data available. By all means, take the graph and then use it, isn't it? Rather than repeating the standard paradigm. Let's not get lazy. That's the whole point that I want to make all of you. Make sure none of you sleep. You can only have a nap for 30 seconds. I'm going to wake you up, right? And then we're going to have also a problem by attribution, meaning you have a signal. You want to see how do I explain this signal, yes? So science, the holy grail of science, what? It's about causality, cause and effect. Right? So we want to examine all the available factors that can explain possibly what the global warming and global changes is all about. In particular, we will talk about the sun, of course, because that's the area of research that I've been focusing my heart and soul on. And we will introduce the problem with IPCC's approach versus our approach, because IPCC tell you that you are supposed to look at this particular measurement of the sunlight output, only one of them, but we show that you can study up to 27 of them. And that's a very strong difficulties and contrast with the IPCC approach. So United Nations, IPCC, I believe that everybody know, right? If you don't know, please raise your hand. No one dare to show that, right? Anyway, everybody knows. They're not a scientific body. They're essentially providing you review status of all the science, and they always say that they are the most comprehensive, they are the most up-to-date, they're most this and that, right? All of it not true. That's the problem. If it's true, any of the aspect is true, I would say I will agree with it, because I'm not the person who want to sell you what you call the the bridge in Brooklyn, right? For $1 or something. But I'm not that kind of a salesman. I'm interested in nothing but the whole truth. That's the whole problem. And then so far they have published 6 assessment reports. The first one is 1990 until the latest one was 2021. In case you are curious, obviously they're not going to stop. So please be aware that AR7 is expected 2028. So a few more years from now, 4 more years. But their most iconic statement that I think just about everybody here is basically observed global warming since at least 1950 is mostly human caused, right? And it's unprecedented. That is another question. We're going to address only the mostly human caused aspect. So the question is very simple. How do we reach a conclusion? Is it scientifically justified? It is not a rhetoric question, isn't it? We really need to answer that confidently. My short answer is very simple. It's just basically cartoon science. It's not a real thing, so it's not scientifically justified at all. Okay? So let's start with the iconic graph, right? Everybody have seen this, yes? It's a global temperature curve, they say. And then they say that, well, this group from England, head crew is England, NOAA is NOAA, the United States National Oceanic Atmospheric Administration. Berkeley, UC Berkeley have a group that did this kind of thing. And then Cardau, I forget where they're from, but they are one of those, right? Simply maybe East Anglia, UC or East Anglia. So they compile a record like this. From the look of this temperature, it looks very interesting, right? There are some cooling and then kind of warm up and then barely and then keep warming up. I want to emphasize, show another graph because I am unable to produce a global temperature. I want to explain why it's not global, okay? It's very difficult in a minute. But let me start with Northern Hemisphere where we have some confidence. So we look through all the thermometer stations available over Northern Hemisphere, on land, of course. Then you try to see that whether whatever the IPCC plotted, which is all the orange, tinge orange curve, our result, the one that I do independently because I don't follow people, I just do independent checking. That's the important science quality, is the black curve. We can agree that I can recover that. Are we agreeing that it's a full replication? Yes? But the only way I can do that is that I have to use not only so-called rural station where it's not so confusing, but you have to include all the urban station available. I want to explain to you that the only way to achieve this result is you must have the urban station. And then the problem of urban station will be what we'll discuss next, yes? And you will see that it's not a very good idea at all to use urban station in this kind of temperature record, let alone studying the causal effect, because the effect from this kind of thing, you are basically, if you try to fit CO2, yes, you can do that statistically and all that. You can do that in a climate model. But you realize that you're explaining something else. You're trying to look for a cow, but then you actually got a little calf, little lamb and going around. So it's dangerous. You're not doing real science. So I want to confirm for you that in the paper that we published in 2021, we are able to replicate this temperature record. This is the first statement that I want to address. IPCC in 2021, AR6, the 6th assessment report, did make a very strong statement that the temperature record that they produce is very, very good. It's very, very robust in the sense that if you want to talk about urbanization or urban heat island effects, they basically say that, it's such an old problem. Everybody knows it. They already solved the problem. But you know that they're playing this as a political game. They had to put out a number. They say, we know, everybody understand. When you go from urban city to the rural station, you know that it's warm, tend to be warm. Even your car thermometer is telling you that, right? You're running from a rural area, you come in, it gets warm, and then when you go back, it cools. Yes? Everybody observe that phenomena, so we cannot kind of bullshit them a lot, excuse the language. But they say we have to constrain that. They say the effect is so small, it's only 10%. And we want to show to you in our scientific work that this is just not a right statement. It's wrong. So take a little bit to explain. It's very complicated chart. Like I say, the slide will be all fully available. Please look at the Clintel website or our website to get this kind of graph, right? All my slides here can be used, and I'd really encourage you to use it, adapt it to your own talk to other groups, yes? So what is attribution science? The first thing you need to know is this language called hindcast. Hindcast is nothing but basically the opposite of forecast, right? You try to look at what happened in the past and see whether you can explain it. Given some ideas about what you think you understand about the physics, what are the causal factors? That's what IPCC is attempting. All of these are very reasonable, by the way. So we are showing you that the iconic graph in IPCC, meaning that every single assessment, they will do something like this. Okay, let me focus in. They will basically try to tell you that on your left, you have the observed temperature record, which is the black solid line. Then you get a bunch of model produced, kind of model runs, okay? And the blue, these are all the blue wiggly curve, and then of course the average of them will be the thick blue line. This is basically the one that when you study this forcing, this pushing of the climate system, you only include volcano and the sun. No man-made factor, no CO2, no methane, all that stuff. Then when you come to it, this side here, that you add the anthropogenic forcing, look, they agree. It is a very beautiful result. If this were to be true, by the way, it's kind of impressive, you know. But it's a graphical tricks. They don't try to explain to you that, first of all, the black curve they use include the urbanization, urban and rural station, so that's very bad. You're not explaining anything. Whatever you explain this is not a real explanation. So finally, because that they can fit this, so they say this is mostly human cause. That's basically what I call stale manning. You see, I'm no longer interested in just doing straw manning. We have to put the best argument out for IPCC. How good is this? I can tell you that it's rather weak, isn't it, right? So I'm going to explain now all the problem involved. So we start with the thermometer data, I think. Oh, there's another slide that I should put up. It's complicated, but just look at the yellow and the red curve. I don't even care which one is the observed, okay? One of them is the observed. One of them is just, everybody knows statistics, yeah? You know, you take 10 numbers, you average them, that's basically statistics, right? You average them divided by 10, right? What is the average number? But if you use statistic, first of all, IPCC is very fond of making themselves look very credible, very scientific, this and that, right? All the gobbledygook, okay? As you know that they say we represent the climate using physics, okay? Mathematics, all the principle, you know, very, very nice. Fortunately, it's not very good physics, not very good math either. So my good friend, by the name of Willie Soon, he's an amateur guy, but he did something very simple. He said, well, if the observed temperature curve is this, and then IPCC have given that all the relevant climate forcing, so which means all the explanatory variables. So he just used that aggregate numbers, but they say that, okay, climate model. They say climate model produced this result, correct? But the filter of the climate model is a bit not impressive because a climate model have about 2 million grid cells, depends on how large you want to represent your region, 400,000 line of code, which is in all Fortran code. Yet, and of course, run, you know, if you want to run this complicated climate models, you know, it takes 88 processor. But what is the output? The output is nothing but just a short regression because the R square is rather high, right? It's almost perfect explanation of the thing. Do you understand what I'm trying to show here? The point is very simple. They try to make it very sophisticated. You know, a whole lot of shaking going on. Nothing, basically, right? It's just a lot of statistics shaking, nothing. No results. Anyway, this is no wonder. One of my favorite physicists now is John Clauser. Yes, he was just with us at IKE conference in Vienna. He actually put this quote out in one of his speech in Korea last year. He said, IPCC is one of the worst sources of dangerous misinformation. I think it captured the context of what I'm trying to get across, right? There's a whole lot of shaking going on, but nothing happened. Anyway, what we do is this. So we have published a few papers recently, actually quite a lot. But we mainly address two of the major papers that we publish. The first issues that I want to address here is to zoom in on the land component, the temperature record, the thermometer station, you know, the detection part, right? So we will show that most of the problem is related to this thing called the urbanization bias and urban heat island, how they affect the thermometer record. And then the second part of the talk will be on this so-called estimate of solar activity, represented by this variable, this quantity called total solar irradiance. It's mainly just the integrated all the wavelength of the sunlight emission, yes? Because the sun don't emit just visible light. It does even ultraviolet, X-ray, all kinds of wavelength. You try to do that kind of measurements. And I want to show you that it's by coincidence indeed. Like I say, we found 27 different TSI index to study, but IPCC insists there has to be only one. And that one, I think anybody believe in coincidence? By coincidence, that is the one that comes from the low variability. So to de-emphasize the role of the sun. Well, the main result we already published in 2021. It's a major review article. And we have about 23 co-authors from 14 countries and 500 references. In our 2023 paper, actually Marcel and Rob DeVos actually joined us. And even 2022, we have one. But this article has been very well cited or downloaded, so people are a bit angry. By the way, we produced this paper in 2021. IPCC said that they could not include this result. What's the reason? We are a bit late for the deadline. And yet they claim that they are the most authoritative, the most up-to-date of everything. They don't realize that when they make that statement, they actually make themselves weak because they're no longer the most state-of-the-art, because this is the state-of-the-art. And first of all, you know what, how we do science, right? I believe everybody agree with this. If there's anything wrong in this particular paper, you know what, we should point it out. But so far, I don't think it has anything wrong with it. That's the whole problem, right? So we're doing real science. And then, like I said, Marcel said this table is very complicated, but I only want to compare the IPCC in terms of the number of their citation, the references they use, versus our paper, the 2021 paper. So let's focus on the total. IPCC report, AR6, 2021. In terms of the topic of the sun as a climate driver, this column here on slightly to your left, and then urbanization problem, they cited about 96 papers, okay? If you study our paper, Connolly et al., we cited 420. I mean, that's who is more comprehensive? Clearly, we're more inclusive. IPCC is doing straw manning, we're doing steel manning. That's a big difference. We want to know everything. By the way, science has such a thing called you can reject certain things. You know, like that's the power of science, that we can reject wrong idea, wrong result, wrong all these things. The stuff that we are showing here is that you simply cannot, there's no basis to reject the 27 TSI record, what we call, right? IPCC insists it must be only one. So that shows you the strength of our work, so I no longer need to apologize to IPCC. I think like Greg and a bunch of our friends say they should apologize to us, isn't it? Like I say, after 22 years of IPCC, if you can dazzle them with brilliance, which means their science is rather weak, you dazzle them with the number of pages. This is just a very simple accounting about how they increased from the first assessment report, nearly 170 pages, down is up to 2,000. You can easily predict what the AR7 will be, by the way. That's a very nice game for us to play, isn't it? They will keep increasing, for sure. Volume get bigger, so nobody read. In that sense, it's a bit of a game, right? Anyway, let's not talk too much about this subtle little thing, but let's talk about now the temperature record. Like I say, we do have a few information, but they are not perfect, and it's difficult to try to understand. Even if you have the data, you want to know what it means. So the land is measured by weather station on thermometer record. The bill is one of your oldest one that you have, right? Back to, I believe, even the 18th century or even early 17th century. And sea surface temperature is also one of those well-known numbers. We will not address sea surface temperature. It's a very difficult quantity too, because the past data is just basically that depends on your luck. The ship is going from maybe from Holland to some place in Africa. Then you measure samples, you throw some bucket, you measure the water. It's called opportunities. It's just not a very good quality. And then no matter what IPCC say, I tell you, please don't believe them. It's a bit dangerous to truly, really believe them. So the thermometer record, I think, is the best hope because it's sitting in a location, same location, and all you need to understand is that what happened in terms of instrumentation, changes over the environment. So you have a little handle. I told a lot of people that I don't want to work with intractable problem. I want a problem that at least we know what it is and then we can try to understand it. The intractable problem is that we just simply know what the guys do. We don't know what the guy that doing the bucket and all the measurement do. So the well-known effect that we know in thermometer record is actually urban heat island effect, right? We already mentioned the role of it. Mainly it's just changing. Men have changed the environment. There's no doubt about it. We modify, we change concrete. We prefer to do this in a hall with nice places to talk like this rather than do it outside, right? Things like that. So but the key thing is that this urban heat island effect is rather large number. We're not talking about baby point few degrees and that kind of thing. We're talking about something an order magnitude larger than actually what the proposed greenhouse effect warming, even from doubling it, right? From CO2 mainly, or methane, or even nitrous oxide, right? If you don't like nitrogen. And so it's a serious number. It's a big number. But this is the number that exactly that they don't want to actually tell you not to look at. They say that, oh, it plays so small role, 10% the most. So what is urban heat island effect? It's been well known, right? It's known since 1820 or so by a guy named Luke Howard. He's from England. He's also actually, by the way, all the categorization, the formalization, during Charles Darwin time, I presume this guy is trying to follow the same for weather. So he classified all kinds of clouds. All the name of clouds come from there. So Luke Howard is also noticing that actually central part of England is very hot compared to the outskirts. Actually, back then he was already observed the phenomenon. The key thing to realize is that even though urban area, it take up very small geographical size area, right? It's 2% the most over the planet. So 3 to 4% of the land. But you think about it, 75% of all the weather stations available, some of them go from 10,000 to almost 20,000 now, but a lot of them are very short records. So what you call the NOAA and IPCC, we want to keep boosting up the number, try to say that it's important, but a lot of those data are just almost useless, like short few years data has no use. But the number is indeed increasing. But 75% of stations are in urbanization. But another important statistics fact is that since about 2011, half the world population has been already living in urban area. So it is in some sense quite true. People have been experiencing what you call man-made climate change. But that man-made climate change is not CO2, obviously, right? It's actually changing out the local environment. And now I want to emphasize in this particular graph, just comparing weather station available in 1880 to 2000. And the main data sets, of course, is come from the NOAA data set. It's called the Global Historical Climatology Network, GHCN. This is part of the reason why you cannot use the word global as much. The global temperature, think about 1880. Are you confident that you can take all these averages and you call this the global temperature? You don't have 1880 number. Yes, 2000 is okay. I mean, that's fine. That's fair enough. But then you simply don't have that kind of data. So don't randomly buy into their argument. That's the message of this slide, right? And most of the data available in Northern Hemisphere is North America, Europe, and East Asia. That's about it. That's all you have. Okay, now let's come to station. Sorry that I drag you on into this, because the point is that after this, you may get a certificate from Clintel, say that you've been certified, which means you can go explain to people. You really need to use this slide, because it is that lack of understanding that lead to a lot of confusion. All the time they show up the IPCC graph, say, no, that's not the right graph. But anyway, even rural station, I think you have problem, right? You need to take care of it, because all this data, if you accumulate over 50 to 75 to 100 years, there's bound to be some change, Maybe the observer got drunk too much beer or something. So you need to know, like he measured not the wrong time of the day, that kind of thing. So you need to have all this taken care of. Instrumentation, the observational practice over the years. And then local climate is a very obvious thing, right? You have this station, you put it here, and then all of a sudden trees started to grow and things like that. Or maybe even people start building concrete building, things like that, right? And then station move is another well-known thing, so I'll show an example. So it's all over the place. In places like Tromsø, you can see station like this. This kind of not very good sighting in this particular one. But I want to pick one example, which is my two colleagues, dear colleagues are from Ireland. So this one is what you call one of the very rare long rural record. It's from Valencia Observatory in Ireland. It shows you that the original location of the thermometer station is 1867 and 1892 is out in the Valencia Island. Down there, by the way, that's the first transatlantic cable was put, okay? Probably Lord Kelvin was interested in that. And then 1892 to 2001, they moved near the coast, that particular location. Then in 2001, they moved a little bit more inland. That's about 350 meters, as you can see, it's 20 meters higher. So you do need to account for this kind of differences, isn't it? So let's look at it. So this is the historical, this kind of information is what we call metadata, meta-historical data of the particular station. So to do the work right, we really need to have all this information, don't you think? We agree, right? So we're glad to have help from Marcel and Rob to actually have a lot of the Dutch station, the meta-history station, whatever is available, so we take them. So we have it from other colleagues. Later we show you our project. But then there are other people who have different ideas. It's fine, completely fine, the idea, yes? It's okay to have different ideas. But this is their approach. The approach now is the famous NOAA, right? NOAA is the one that produces and collects all the information, the GHCN, the Global Historical Climatic Network, right? There are multiple type of versions, so you have to be careful. There are version 1, version 2, version 3, version 4, the beta version, this and that, right? So be careful. But what they are trying to do is that, they say instead of looking at the meta-station history data, we will apply something called statistical adjustment, homogenization. Sorry for the word, right? It's a bit mouthful to say that. Homogenization, right? And they propose to do things like that. Homogenization just simply means that if you have a station here and the nearby station and 3 other stations, they all should be more or less representing the same trend. The concept is actually quite okay, no problem. The problem is actually reality. How do you do this? Right, yes, for all over the globe, you got to be careful. So here's what happened. So as I can tell you that because we have meta-station data, we can actually adjust for the Valencia data very correctly. Nothing happened here, no change, but up to the 2001 one was well known because you really move inland. Now we want to know what happened. What happened to the GHCN record? What do they do? Let me show you one example. Actually, this is a sample of 1, 2, 3, 4, 5. These are the way that the statistical algorithm program asks them to produce. You can see that each day something is different. When we saw this, we fell flat. We said something is wrong here. Do you understand what I mean? They are proposing adjustment that had no correspondence to reality, first of all. It's all statistical and also random. Because even among the same records, same data, when they run an algorithm, the reason why you keep update is that every time there's an update from somewhere, it doesn't have to be even Valencia, input data from, let's say, Africa or Tunisia or someplace, they come in, they rerun the whole GHCN record. And then everything refresh again. And then by the grace of God, this one I really use the word grace of God, we happen to work with this guy named Peter O'Neill. He's at the UCD, University of College Dublin. And the genius of O'Neill is basically, in 2011, he was interested in Valencia station, one station. But then he need to download all this data, the raw data from GHCN. So version 3, in 2011, once he realized something wrong, he already downloaded 3 versions of it. By 2012, the version 4 is still not coming in. So he had 39 versions, so on and so forth. By now, I'm sure because he still collect until today, by the way. Every time they update, we go to the NOAA website, we download the whole database. So we have about 2,000 version of version 3. Version 4, we have also about 2,000. Even the beta version, we have it. You know what this means, right? This means we really have a very interesting database. We have a way now to try to study how do they produce this statistical adjustment, isn't it? So in 2022, this is, by the way, with God's grace again, because we have the data, and with all the friends willing to help us, especially your prestigious Dutch group, they're all willing to help us. We work together. All we ask them is that, can you give us the station history data? A lot of these authors, they don't agree with us. They pro-IPCC, no choice, because they are from the individual countries' meteorological institute. They are the one responsible for the data. So they know where to find the station history data. So we started to look at the European temperature record, right? And the bottom line is this. The bottom line is summarized in these 2 pie charts. Please don't mind me for simplifying. You should read the paper, obviously. But I don't want you to get too much headache out of this. But you see, the first thing that we did is that because we have so many versions, 2,000 versions, without even any input from anything. All you need to study is that for that station, for whatever station that we have, right? Actually, for European station, we got almost quite a lot of GHCN data, okay? But we have only like for 2,000 of this version, we can study how consistent every day each of the version agree with each other. You know, that if I jump, it's only one like this. Next time, does it look the same exact like this? Now they start seeing this, so it's not consistent. So we only find 17% of this adjustment is consistent. Then the next question you ask is very simple, isn't it? The next question you ask is very simple. The adjustment they propose, statistical adjustment, do they correspond to the station history? It's only 20%, okay? Actually 19, yeah. So that tells you that 80% of the adjustment have no correspondence to reality. Do you understand how significant this is? I think actually Noah and all those guys are rather embarrassed. I don't think they want to talk about this. We actually try to communicate with them, obviously. So we got more work to do. And then there's another class of problem that I don't want to give you more headache, but I want to tell you at least the physical effect. Every time you do this homogenization, you are always risking the quality of your good data, which is the rural, which you still need to correct by the station history. But every time you have a partner in this homogenization, anytime you have slight urbanization in one of the record, you will contaminate because you try to homogenize everything. So what we call this is basically the urban, this is one of this urban contamination problem into the even good record. So you ended up having not only bad record, but the whole thing is contaminated. We have shown this thing in Japanese data. Okay? So this is the kind of problem that we want to avoid. So our recommendation is that never ever use the homogenization data, homogenize the temperature record from NOAA. You just rather use the raw data and then look through the station history and correct for them, whatever correction you can do. So this is what we did. In 2015, we already have the insight, and then 2021, we produced the full version, right? We study all the 10 to 15% of the rural station available because most of it are urban. So we just asked the question, can we not look at the urban station? And then don't look at the homogenized version. There are papers who show that the homogenized rural and urban agree with each other. But they forgot to say that that's the proof, by the way. That's the proof that urbanization is already, urban station has already contaminated into even the rural station. That's why the trend agree. But you look at the raw data, you correct using the station history. So these are all the stations we have. Even though it's very small percentage, but it covers 90% of all the rural record available. Okay, so it's rather significant. What we think we produce is reasonable. It's not the final word. Of course, we have more time and data, we will do this. So we have rural station from US, from Arctic, Ireland, and China. In fact, the hardest problem is Arctic station. There are quite a lot of them. Are kind of hard to correct because we don't have the station history. We try to back the Danish Meteorological Institute because they own a lot of those things. And then many people won't give us the data. Well, we're going to work on that later, of course. We're going to keep trying. And now here's the final bottom line. More or less on the top chart to your right is what you call urban and rural station combined. That's the one that you have seen before that promoted that for IPCC. That's what you should use. And then the ultimate graph for us is basically the rural station only. You already immediately see the character is so different, right? If you try to fit a trend line to this linear trend line, just straight line going through, you can see that the trend for the urban and rural station is actually 0.9 degree per century. And then even though this one has a different character because it has kind of oscillatory one cool, right? You actually can also fit the trend line, it's fine. But you get about 0.6. Immediately you see that this problem of urbanization contamination is not a 10% problem. Much, much bigger than that, okay? So we at least show that the IPCC is not quite right on this particular point easily. So what to do? How good is this rural station record, right? It is a very difficult, not so easy to answer, by the way. So we try to see, like I say, the weather station record is the best, really among the best that we can do, if you know how to correct for the problem. But we have also sea surface temperature, so we have some attempt, at least some data available. And then you also have things like tree rings and lake sediment type. And then you can also have things like, I think even the ice core and glacier stuff are available. Whereas a lot of other well-known results like weather balloon or satellite record, they all started late, okay? So let's put them all together. Let's study them. How does it look? Again, our rural only temperature data, Northern Hemisphere, is actually on your top left, right, in that panel. The sea surface temperature record, look at it carefully. It has also that cool, warm, a little bit cool, and then warm again. Yes, it has similar character. The three ring ones was particularly appealing in the sense that it does look the same. Yes, and then the glacial length record also shows that. And then whereas other record, basically they start pretty much late, so you kind of have similar consistency, but it's not definitive. Yes, one wish to know the ocean heat content back to, let's say, 1850 or so. I'll show one of the results later. Yes, next. So bottom line is that this phenomenon of a warm period that even Greg has emphasized, the warm period, the first warm period of the temperature record from 1920s, 40s, and 50s, this is a real phenomenon. IPCC indeed has admitted that these are very natural and very large changes is real. So in the first IPCC report, you can see somewhat still honest, isn't it, that they admitted that there's such a thing. And then if you ask them today what happened, they probably won't explain to you why. Yeah? Why does the record all of a sudden disappear? Why is it that the record has been changing quite a bit? Okay? Actually, they have done something also to the sea surface temperature, but we won't discuss that today. But this is on the ocean heat content. This is a very difficult thing to know. But unfortunately, the result I show you is actually not real data. Okay? It's a data assimilation. It's best ocean model that you try to assimilate all the information you can, because measuring heat content is a very, very difficult task, right? You really have to volume sample the whole column and the whole thing, 3D essentially, to integrate to get the heat content in it. So it's a very, very difficult measurement. If you hear people trying to sell you that they know all about heat content, don't listen to them. It's nonsense actually. Even the Argo project, the famous Argo project, you know, the buoy that they put on the surface with the robot, and then they go now about 2,000 meters and come out and sample things. Those things have only record like from 2003 until now, so okay, 20 years, fine. But good record only come out in 2013. So we still have very short record. It doesn't kind of tell you much actually. You know something, but not too much, okay? So let me move on now to the attribution process. This is about studying climate change now. If it changes, why does it change? Right? So we'll talk about for me, the main factors will be the solar, yes? I will mention a bit about what I think about volcano. Then we will also study the 11 human-caused climatic driver that was recommended by IPCC, yes? So this is what IPCC call. All the man-fat is very prominent. They count up to 11. They would call this a smoking gun, by the way. So the CO2 is over here, yes? CO2 factors. And then you have methane, the cow fart, and then you also have the nitrous oxide. It's actually a laughing gas, yes? So it's not very, even all that they count stratospheric water, they count contrail, you know, aerosol has all this strange property, and aerosol is also a very amazing story, right? They only count sulfate aerosol, but in nature have about 100 different types of species of aerosols. They pick only the sulfate aerosol. It's very convenient. A lot of this research is actually less appealing to me because they are not about science. It's a bit like, I don't know, all kinds of crazy things that they're doing. So for the natural driver, it's volcano and solar, yes? Solar, I hope you see that it's very unimpressive, isn't it? I have to tell you, if IPCC were to be even anywhere near correct, right, I can tell you that I'll stop the talk now, we'll start drinking beer and get drunk. It's impossible. This thing is just crazy. It's not true, actually. I will show you why. But even volcano, I felt very sad for people in volcanology. Because volcano, as we know, is rather a complex system, isn't it, right? You have magma, you have I don't know what, the mental stories, you know, with the heat, specifically, probably some tide can affect it, and then erupts, right? And then what do? The eruption, no two volcanoes are the same. No, you get water vapor, it can have sulfur, it can have all kinds of things being erupted, even dust and particles and so on and so forth. But IPCC cleverly tell you that you should only parameterize in terms of something called a radiative forcing, isn't it? In fact, Marcel was interested to know why is it that some of it are positive. He said essentially to have the positive to cancel the negative, so the net forcing will be very small, really, in some sense, right? So in combination, look, the man-made part versus the natural part. It's just there's no chance at all for the sun and a volcano to cause any climate change, really, right? And it's always the anthropogenic forcing. And then especially since the 1950s, this is part of the, what you call the narrative that they have already set. And then all they need to do is to make sure that they got the numerology, the numbers correct, so they fit up with things like this. It is not an accusation. This is just pure facts. That's what they're doing, okay? So yeah, that's what IPCC is doing. Put a little stick and maybe they need a match, but they forgot about the match on this one. But now we're going to move on to the sun, which is my favorite subject. I call it Mr. Bob, right? The bright orange ball. It is very strange, really, if you think about it. IPCC say the sun cannot cause the climate to change. Very strange. So let's put some numbers. The first thing you realize is that sun really is the only power source for the whole engine of the earth, right? If you think about the number, it's about 2 billion times weaker, 10 to the 26 watt. Here, 2 times 10 to the 17. Even that number, you know what it is? It's just a converted energy from the sun, right? Converted solar energy that deposited on the different reservoir. Because we know that the earth intrinsic energy heat coming from the earth is actually so-called radiogenic heat, right? That actually you can constrain them. You measure geoneutrino, basically the neutrino make in the core of the earth to estimate how much it is, right? And that number is quite reliable, actually a factor of 2, basically. It's done by the Gran Sasso, the Borexino group in Italy, and then the Japanese Chinese is doing. So that number is pretty much also very strong. But all we know is that there's no way. Remember, can you guys tell me what is CO2 do to the climate system? It's clearly not an energy source, by the way. Or else Al Gore will be very rich, because once we have an ice age, he should really sell all the CO2 that he has, right, to heat up and melt the ice sheet. It's not a heat source, right? It's not a source, you know. The way you add more carbon dioxide is very simple. All you do is you change the rate of cooling. But it's not an energy source. That's the whole point. I even get into argument with the Nobel laureate, Steve Chu, you know, the Secretary of Energy of US, right? Who keep claiming that he can use a CO2 laser to melt the whole ice sheets of Greenland ice sheets. I say, how? It's an improbable statement. This is the kind of confusion that I don't like, which means is really, really artificial science. So I ask a simple question here. Could IPCC, they obviously refer to IPCC, could they have underestimated the role of the sun? Yes? No. They could not overestimate, but they can. So, sunspot. Okay, no sound, but that's okay. I don't sing, it's fine. But I want to say that, you know, the number one features that we know about the sun is sunspot, really, right? It's the oldest feature essentially noticed by man, right? When the most important thing is that Galileo Galilei, well, anyway, sunspots come in such a varieties that one has to be also a little bit more careful, isn't it? So you have large individual spot, a large group of spot. By the way, the extent of the sun is such that you can fit a 110 of Earth inside the diameter. You do in 3D, there's about 1.3 million of this Earth you can throw the balls in if you know the spherical packing problem. But anyway, you have umbra, penumbra. These are all complex magnetic structure. We know that sunspot is very intense magnetic field region on the sun. It's about 10,000 Gauss. On average, the Earth's magnetic field is only 1 Gauss, right? So think about it. And then you have complex structure like this, umbra and penumbra. The reason why I mentioned them is that I think that we sort of need to understand how that property changed too as well if we want to study the integrated sunlight output, right? That is a very hard problem, by the way. So Galileo Galilei indeed has started the first point, and then many observers has been keeping the record of sunspots since 1609 or so. So it's 415 years now, right? We got a very long record now. And then you can see there's a particularly very well-known period where the sunspot more or less disappeared. Only in the northern hemisphere. They still have it in the southern hemisphere, but very squeezed. It's at 10 to 15 degree latitude. So that actually, the reason why I know so much about that is that I did produce a popular book on this. By the way, if anybody wants to read them, please ask me. I'll send you the PDF how to read, yes? So it's a lot of problem actually to understand that how does the sunspot number, how does the sun's irradiance change? We want to get that number, which is a very difficult thing to do. You need to use satellite, obviously. But then the problem is that satellite is only a very short record, started in 1979 or so. So you need to know what happened in the past. To know that, you got to use something called solar proxy, isn't it? The few things that I mentioned is penumbra-umbra ratio, and then you can measure many more things, because every time the sunspot comes, there's a region that instead of dark, is called bright region called faculae, and then in Latin, the dark part is called maculae, yes? So you need to study that, but that measurement is very hard, the faculae part, because you need a contrast, things like that. So there are all kinds of complications, but I'm trying to tell you that everybody is working hard to try to do this. But IPCC is essentially telling you that you only need to study sunspot, and in fact, use only sunspot number. That's the thing that I want to tell you what they recommend. So this is just an illustration. When a sunspot passes the central meridian of the facing us, it's all kinds of things that changes. That one is a white light output. That is magnetogram. Basically just measure the magnetic flux. And then you have the UV emission, you have the high UV, and then X-ray. It does come in varieties. It doesn't always follow each other and things like that. Look, the shape is completely different. This is why you need a very sophisticated measurement technique, right? And here's the bottom line. After some 40 years or so, I call this an embarrassment of solar physics. It's true. Even the solar physicists now all bought into this IPCC, so nobody's studying science. It's a very strange phenomenon for me. I've been trying to learn about the science for a very long time. So in here you have about, actually the number is not 13, it's about 16 or 17, but there are actually more instruments. Each time is that you try to put this instrument, it's called cavity radiometer. It's just a pinhole on a little black box that you try to have a very sensitive thing so you can measure the total amount of energy going in there, you can measure. So you integrate, you look at the sun, you point at that, and then you do that. Look at the data. Absolute calibration, we don't know anything from 1359, 1358 to 1374. That's a huge watt number. Has more than 1%. The reason why this chart is important to show to you, I want to show the next slide, more or less capture the same way. I'm just telling you that one of the hardest problems in solar physics now is to ask the question, how do you put them all together? Do you understand? How do you put them all together? And we are working on a very important paper right now to explain how you do it right. Of course, the choices is that there's a lot of redundancy, so you cannot have an absolute one answer, isn't it? Not the IPCC type. Another important thing about why we must get this absolute unit of the sun irradiance right is exactly the problem of climate model. Think about it. There's a famous, all the climate model, when you say that you have the ocean component, and air component, and sea ice component, and the ice sheets component, you try to let the system run, right? You don't do anything. Without anything, you will see. For example, the well-known one is the NASA Goddard Institute for Space Study, E2 model. Okay, anybody who wants to know details, is that when they run it like that without doing anything, they have 3 times more ice on the Greenland ice sheets from actual measurement. They have 2 times more in Antarctica, and then all kinds of discrepancy. So what to do? What to do? Huh? If you don't know this absolute irradiance, you just move the sun a little bit inner, nearer to the Earth. The Earth a little bit nearer to the sun. You solve the problem. It's called tuning, yes? No matter what they do is tuning. That's the problem. And they say they have all the model right. So one of the consequences is that how you combine this. I only don't want you to focus on too many graphs, but the main graph I want to focus you on is the middle one, PMOD, P-M-O-D, the group from Switzerland, okay? And that graph is amazing in the sense that the actual recommended measurement, the TSI, these are how they choose to combine. So this group say that we got to combine like this. And then if you scale it with the sunspot number, okay, it fits. Miracle. But this is the kind of group that the data that actually IPCC recommend to use. Actually, if anything that you want to bet your money on, I will bet my house and the whole thing on this actually. If this were to be correct, I think I should go crazy. It's impossible. Because you know what I mean? The sunspot number, SSN, when it's 0, it just means that you count the number, it becomes 0. So from one of this cycle to the next cycle and next cycle and next cycle, they're all the same. It's impossible because if you look at the actual measurement of the sun during minima and any of this, you measure anything you want, UV wavelength or calcium H2 and K, all kinds of measurement, faculae and all that, they are not the same. This is not possible. What I'm trying to tell you is that actually in our paper that is working now, we're actually able to show that a lot of this is because the group here, by the way, that person died already, but he actually started to adjust them by hand. He wants to fit certain paradigm. It's terrible, actually, to do that. That's why it takes a lot of work for us to figure out what happened, right? So the rest of it is that, indeed, group like this group called Acrim, they're from JPL. In fact, I'm sorry, I had to announce that I work with some of their co-authors that responsible for Acrim data set. But Acrim data set showing you that, the minima is quite different. If you look at one of the minima from 86, it go up in 96 and then it go down. So it does different things. And those tiny trends, by the way, is enough. It's enough to explain a lot of things. Just want to tell you that's the significance of it. So the bottom line is indeed that if you want to go back, because we want to study let's say the thermometer record, you need to go back 1850, yes? Here, because you have the sunspot information, so you can go back to about 1700, beginning of under minimum, right? So the consequence is huge. The pre-mod one is right here. Is this result here, right? In fact, they did even more. They did even more in their actual thing, in their final recommendation, because they use model. They actually add one more component, so they looked at the bottom change a little bit. And then the famous RMIB, which is the Belgium group, because Belgium group produced a sunspot number, the Royal Observatory of Belgium. This is Royal Meteorological Institute of Belgium. They actually fit exactly like a sunspot. And then there's another choice, which is a well-known choice because it's done by my colleague Douglas Hoyt. He proposed that in 1993. He used not only sunspot, he used a cycle length because the length of the sunspot represents how strong or how weak the activity is. And then he also used actually the penumbra and umbra ratio. He used a lot of good numbers to try equatorial rotation rate. That tell you how strong or how weak the solar dynamo is. So he actually proposed this. I kind of like the idea because it's very, very difficult to think that the sun will be representing and captured by sunspot number alone, right? So it's much more, you have a sense that it's much more physical, but we don't have definitive proof, obviously. But I can tell you other things that I do that give me the sign that this is very, very interesting. So we do have 27 pieces of puzzle, yes? And this is them. It's all of them. So finished, right? 27. But I want to point that out now. So the choices, the number is basically 8 from the Acrim calibration, 15 from the PMOD style, 1 community, and 3 sunspot number base. So this is the result that we just produced in 2023. One of the paper, Marcel is involved also, and we produced such a paper, right? And I want to show you that what IPCC has evolved. From 2007, the AR4, they actually recommend 6 to 10 TSI record. And one of the famous record that we recommend now is the HS93, Hoyt and Shorten, the one that used 5 solar proxy. It was at one time was admitted by IPCC that this is an admissible evidence, put it this way, right? Now it's no longer so. You ask them the reason, there's no reason actually, right? The next one is the 2013 paper, AR5 report. AR5 report recommend 4 of those, as you can see. And then you can imagine the final one is this one. Nothing but 1. So everybody must unify. That's what IPCC is saying. I just tell you that this is very unsustainable. This is very anti-scientific. So, we got to really say it as it is. So I hope that IPCC will come and challenge us and see what's wrong with our paper and things like that, right? That's how then we can carry on. But I want to recommend that, there are 8 of this, that you cannot reject this. Because it's very, very reasonable. I want to add one more thing. Science is about constraint, right? Because I become a bit well-known, not because I go on Tucker Carlson's show, but in 94, I produced a very interesting paper that I estimate how much the sun can change, but not from direct observation of the sun, but observe sun-like star. In astronomy, we have an idea to do this. And we provide a constraint that changes very similar to this CRIM result, really. So by 94, I already established that. Until today, there's no need to change my result, really. No reason. That's why IPCC cited my paper, that paper, in the second assessment and third assessment very positively. And of course, it disappeared again. So I want to ask a very simple question. Can you really honestly say this choice is correct? Please answer for yourself. I am not convinced at all. That's all I can say. And I think that people should be aware. What IPCC is giving you is not only third-rate science, it's really cartoon science. It's not serious at all because there are so many choices. Even by picking choices, he don't allow you to pick. That's how complicated things are. So indeed, no wonder that people say there's a very important scientific study, prove that the result of a scientific study depends entirely on where is funding coming from. I got nothing, so it's okay. So I'm not biased in that sense. So quickly, I want to show you our two papers, and I want to show you now the best understanding, how do we attribute. So this paper we published in September. Marcel Kroc is on it. I'm grateful that he joined us. And then we also have the 2023 paper, October, another paper. And in this particular paper, we expand what we did before. We try to use all the 5 temperature proxy that I show, with 3 rings, sea surface temperature, rural station, and then of course urban and rural, because you also have to include that IPCC point of view. And then you study with the 27 TSI record to see whether we can, what can we say? Because IPCC say that basically using the TSI record, they recommend the sun roll is nothing. So all the changes in since 1950 is all man-made. But we show that, look, you have all these choices. You have 5 temperature record, 27 TSI. So let's look at the rural station, rural thermometer record. On the left there, it's only including greenhouse gas forcing. You can see the red line. It's kind of impressive, yet not impressive, isn't it? It's curve fitting. But in the curve fitting sense, we show you that it's not only the Hoyt and Sharton record, but we can have a varieties of others. They kind of fit the temperature trend of the rural station rather well, isn't it? It's not bad, but again, it's statistics. It's fine. What we're trying to prove is that the IPCC statement about this anthropogenic only is completely not robust. And then to say that the sun doesn't play a role is also not robust. Then you can test the next one with sea surface temperature. Again, the group of TSI estimate from the high ACRIM estimate also fit this data set quite well. Okay, at least 3 of these, the top 3. And then again, you can do that for the CO2 effect. And finally, the 3 rings, more or less similar picture. And let's see now what we can conclude. So I'm almost near the end. The first thing is that, what can we say? What they claim about urbanization bias is less than 10% is simply wrong, isn't it? IPCC, are you listening? And then what they claim about TSI, the estimate of solar irradiance, is clearly wrong, isn't it? I think it's a fair conclusion. If anybody have anything to challenge, please tell me. And then when we actually consider what you call the rural-only temperature record, that is actually a record that we have an idea now to work with Marcel. Maybe we should do the European thermometer record, because back then we were only addressing the homogenization problem, isn't it? So we should actually produce the temperature record and study how it looked like. But take only rural station. Do you understand what I mean? And correct for the rural station record using the meta station history data we have. It's a great idea. Should do it. Doesn't matter if it shows warming or not. All I care is that we produce something that's meaningful to interpret. So that's the next step. So whatever IPCC say, right? I think to say that we can establish global warming is just not clear. You know what I mean? That is the most neutral conclusion we say, which is to say that, the conclusion of IPCC is premature, that it's all man-made, isn't it? So, and then there's another topic that I would not address here because they took out all my slides, but it's okay. But it's a very important question to ask. The question is this. They have claimed that they understand the whole system. But the most important thing, me as a physical scientist, is like, how well can we measure the energy budget in the system? You all may have heard about NASA series data sets. Some of the very deep people would know that. I want to tell you to be careful with the data sets. It's not what it says. Because they cannot close the energy budget up to 6 watt at the top of the atmosphere, up to 17 watt at the surface. So what they are telling you is all gobbledygook. Just be careful. Even the series data, I wouldn't trust it. I want to close with a bit of philosophy now, right? This guy I admire very much. By the way, he wrote me a nice recommendation letter too. So Freeman Dyson, he passed away. He actually made a very nice statement. The central mystery of climate science now is not a scientific one. It's a human one. He said, how does it happen that the whole generation of scientific experts is blind to obvious facts? How is it that people supposed to be the experts who claim to understand the science are precisely the people who are blind to the evidence? Because I think the science is being robbed by the IPCC kind of approach. Everybody joined the group. Everybody got silence. Even you want to say anything more, IPCC say, no, you have all these different governing body telling you not to make those statements. Oh, it's too complicated, too much details. I'm sorry, science has to be detailed. It's all but details, right? So in terms of that central mystery of science, I have to put out a little plug for ourselves. We've been playing this soccer game for a very long time. I like soccer, by the way. And I think the score now is fair to say that it's 1-1, right? You know, we're still playing, but you know what? We're winning that one score goal, but we're at the bottom. I'm at the bottom, really working hard. Ronan and Michael, we've been working hard every single day to do this, to make the science straight again. And then try to engage the middle. I don't like to be too polemical, you know, I want to, you know, let's all come together. Even Michael Mann, Gavin Schmidt, hello, you know, if they don't like me, please let's discuss, right? Don't say that Willie Soon is ugly and things like that. That's not true, you know what I mean? Such a handsome man. Anyway, I call for help. Please come to our website. You can get all this stuff, and please also visit Clintel. Of course, Clintel is a group that I truly admire, and please come to this website, series.sign.com. And then if you are able to help and donate, that would be great, because everything we need, even buying paper, buying ice cream, paying buffet will be helpful to us, because we really have not much money to go on. We can't go anywhere, we can't go visit, you know, things like that. But anyway, help us out if you can, and help Clintel. The most important thing is to come to the website, learn something, and then use it. All our data, by the way, every paper we publish, unless the one that we truly cannot release, like for example, the station history metadata, whoever want to work with us, we will ask them to please let that be available also, so people can replicate. You know what I mean? We don't want to just say, oh, we're God, we're the one, we make no mistake. Everybody should check, really. So certain things we cannot release because we don't own these things. But for the GSCN data, clearly we can release every one of them, right? We just do it properly. Come and help us, please. And use the data. Don't be afraid. Talk to your neighbors. Of course, it's uncomfortable, but you talk to your family. Tell them about the facts. Every time they say IPCC say this and that, you just say, do you know that IPCC curve is not so correct? Things like that. Maybe you have heard of Willie Soon or Clintel. Study the report. It's a reason for why we are skeptical. Because the amount of evidence doesn't amount to much. The evidence that they put forth is embarrassing, actually. It is truly bad for science. Truly, truly bad for any other people. Once we cannot follow the science and just really understand the nature and the quality of all evidence and argument. Okay, I should stop here. Thank you.
Wow, Billy. I'm a bit dizzy.
Did I make it on time?
Yeah, absolutely. You made it on time. I have a small question about the graph on slide 2. No. Just kidding.